So my name is Frank McKenna. I'm here at UC Berkeley working for the Near East Sim Center. This is a short video showing the incremental changes that the C++ language brings to C. C++ program structure, it's very similar to a C program structure. We have our preprocessor commands, functions, variables, statements and expressions, comments. And what C++ brings in now is classes. And it also provides some minor tweaks to the C language for missing functionality. So here is a hello world in the C++ language, and bottom right is in the C language. They are very similar, slightly different. Instead of including standard I/O, we include I/O stream. Note there's no .h. We have int main is the same for our comments now. It's 2 forward slashes at the start of a line. We'll comment out that line. In C, we had the forward slash and a star, and then at the end of the comment we had a star forward slash, so we no longer have to have those 2 characters at the end. For output, we can send things to standard out using the insertion operator. We're inserting the string into the stream, and then finally we both have a return 0, so that part is not changed. So now let us look at how we deal with memory coming and returning to the heap. Before we had malloc and free, they have been replaced by new and delete. Here is an example of new, where we're allocating a double array from the heap. You see it's an awful lot cleaner than before. We no longer have to specify n times the size of double. Now the compiler is smart enough to know that if we want an array of double, it knows the number of bytes to obtain if we just specify the n. Also, we no longer have to do that cast from void pointer to whatever type we have, so that cast is gone. So this new looks a lot cleaner. It is what replaces malloc. And also down here we have, this is what is replacing free. The one thing to note, when you malloc, or when you new an array with the square brackets, here where the square brackets indicates we're creating an array of n objects. When we return the objects to the heap, we have to tell the compiler that this was an array we newed, so we have to put in the square brackets. So now strings, we have a whole new type added to the language, strings. Remember we had that little problem, there was no strings in C. The compiler was automatically throwing in that special character at the end. Now we have strings, and we can do fun stuff with strings. We can plus equals them, we can add a string to a string, and we can send a string directly to standard out. So C++ also now introduces a pass by reference option for our variables. In this example here, I have 2 functions. One is sum1, the other is sum2. Sum1 is what would appear in a C program. Remember C, it can also appear in a C++ program. Sum2 is this new function that's only available in C++, where we have this ampersand C. Ampersand C means it's now being passed by reference. So if we look at sum2, we see it's ampersand C. And if you look at the assignment, it's just C equals A plus B. We do not have to do $C equals A plus B that we had to do if we pass it through a pointer. And calling the 2 functions is different. Sum1, we're having to pass in the address of Z. But in sum2, because this is a reference, we just say X, Y, Z. So again, it's an awful lot cleaner and simpler now to pass by reference. All we have to do is just change the function definition to indicate that it's coming in by reference. Also, what is now provided with C++ is a bunch of built-in data structures. They provide all the common data structures that somebody might use, so the onus on the developer to provide their own library of data structures is now gone. And I'll hold off from providing an example for now. I do an example at the end of the next video. And of course they bring in the concept of class. Now typically when you develop classes, you're going to put the implementation in one file, the .cpp file, and we're going to put the interface in another, the .h file. This allows us for that encapsulation. It means that we can come along later and change anything in the .cpp file, and it does not affect any other program that uses the class. And the .h file, sometimes if we do change the data, the variables that are inside the class, the other code does have to be recompiled, but the other code, as long as we do not change the methods defined in the .h class, they do not have to change. So I thought now we'd go on and do an example.